minutes. Okay, thank you. So this session is meant to last for 1 hour 30 minutes. So I'm going to start the time now. We're starting at 8:19. And the first task is 15 minutes. So I'm starting this one too. So we can keep track of time. All right. So this is meant to last 75 minutes, right? So we'll see how far we can go. So we've already covered these prerequisites. We've read the case study for the lab. And we've also, well, based on what we've done so far in the past week, we've basically covered what data engineers do. The file, if you're looking for the file folder, you can find it in the, if you can't download it, you can find it in the one I shared in the, on my Google Drive. Okay, so by the end of this lab, we should be able to explain why Databricks can be used to help data science projects. We should be able to provision a Databricks instance, an Azure Databricks instance, and create a workspace that will be used to perform simple data preparation tasks from a data lake store Gen 2. So we'll walk through performing some basic transformations in Azure Databricks to get a feel of what the capabilities of Databricks. Okay, so this is the scenario. I think this is a refresher of the scenario we are working with. Is an excerpt from the overall case study. So in response to the information services department, you will start the process of building a predictive analytics platform by listing out the benefits of using the technology. The department will be joined by data scientists, and they want to ensure that there's a predictive analytics environment available to the new team members. So we will stand up and provision an Azure Databricks environment, and so on and so forth. Then we'll test the environment, that the environment works by performing a simple data preparation routine on the service by ingesting data from pre-existing data lake storage Gen 2 accounts. As a data engineer, it has been indicated that you may be required to help the data scientists perform data preparation exercises. To that end, you have been recommended to walk through a notebook that can help you perform basic transformations. Okay, so I think the first task here is to first of all, explain what Azure Databricks is. What are the benefits of using this technology in this particular scenario that the information services department is requesting our expertise. So we are being presented as senior data engineers right now. So hello. Yes, Daniel. Hello. Daniel, I can barely hear you. I can't even hear. I can't make out anything you're saying.
Yeah.
Kemi, do you hear what he's saying?
No, it's cracking. The network is bad. The voice is like on and off.
Yeah. Like it's really, really bad. I can't hear at all. Why am I muting myself? I'm not sure I get what you're trying to say, Daniel, and I can't even see the chat, so you can't even communicate with chatting. So I don't know. Do we have a whiteboard? Sure, we have a whiteboard here. You can write on. So I'm just going to continue, Daniel. I hope I'm in line with what you're thinking, Sha. Going to continue. Okay. So before we continue, let's just look at. Let me just bring us back to where we the scenario identified to use, because we the Daniel, I didn't hear that. No, I'm going to. Nah, this is not going to work. Let me share my tangents. No, Google Docs. So you can write here what you're trying to say. What's wrong with my network? Just a minute. Okay, let me share this. Seriously. I'm just going to drop it in the WhatsApp channel so you can edit. You can just write what you're trying to say, and I'll see it. So because I can't hear what you're saying at all. Okay, where's all right. Okay. So I'm going to just continue to check back on this. Okay, so we so we came to the conclusion that Azure Databricks will be the best technology to go with to satisfy the data requirements of developing a predictive analytics capability. So want to know where is that? Okay, so yeah, the first task is to from the content that we have learned so far in the course of study, we should identify the digital transformation requirement that Azure Databricks will meet and a candidate data source for Azure Databricks. Okay, so we've part of this. We've determined them taking the editing the Google Docs, Daniel. Okay. So we've identified that we've identified part of it. The data requirement is to build predictive analytics solution capabilities, right? That's the requirement. You should have, whatever technology we use, should have predictive analytics capabilities. Okay, so the next part is to identify a candidate data source for Azure Databricks. So let's look at what these people, excuse me. Okay, the Information Services Department. So what exactly do they want to achieve? Like, where is their data coming from? Or what kind of data are they storing that might inform us of what kind of data source we should use, Or I already know the data source they used in information service. Okay, there's no information service here. Customer service. Okay. All right. I don't think there is any information service particularly here that will inform us of the kind of that will inform us of the kind of storage that we should use. So according to, further down, they ended up using a data lake Gen 2 storage. I think they even discussed it here. Yeah, so a pre-existing data lake storage Gen 2 account. Okay, so so let's discuss on what Databricks is. What Databricks is about. What exactly is Azure Databricks, right? So Azure Databricks basically is as Daniel, I think Daniel mentioned it in one of these days where he was presenting. Like it is majorly used for compute, right? It is the compute platform that leverages on Apache Spark, right? So Apache Spark is a general purpose open source distributed. Okay, it's open source first of all. So what that means is that it's not owned by one particular company. The whole community is responsible for maintaining it, developing it, and adding new features to it. But many companies, including Azure, AWS, Google, and some other major players, they have their own. What they did is they clone it and then customize it to suit their own, their platform and their kind of services that they provide. So they make it interact with, for example, in Azure, you can use Databricks to connect to all kinds of data sources that Azure supports. So that's the open. That's why it's called Azure Databricks. So I'm trying to say that AWS also has their own version of Databricks. So does Google and other guys. So it's also general purpose in the sense that you can use it for a lot of things. You can use it for majorly compute, but you can use it for developing machine learning algorithms, graph computations, and there are a lot of things you can use it for. You can use it for a whole lot of things, right? So it's general purpose and it's distributed, meaning that I mentioned that it's a compute platform. So by what that simply means is that it uses computers, for those computations, and those computers are distributed all over the world, and there might be hundreds of thousands of computer data warehouse. What do they call these things? computer warehouses, where all these computers are, right? Wow, meant to have finished task one. Anyway, so it's distributed, meaning that it's not just one computer that is responsible for all this, or one computer in the cloud somewhere. It is distributed all over the world, right? And what now happens is that you can now cluster all these computers based on your specifications, right? That your needs, you can cluster them, and yeah, so it is a distributed cluster computing framework. So that's just all that big grammar. I've just like explained what it really is. So what Databricks does is that it provides an interface for programming the entire clusters. So yeah, so it gives you a user interface where you can specify, oh, these are type of clusters I want. So clusters usually means a group of virtual machines. Right? It's just machines, it's just computers that are distributed all over the cloud. So you can use that the UI before, right? You would need to really like know all the hardware. You need to know how to configure it. You might need to study years just to understand how to configure all these things. But now with the click of a few buttons, you can get your project up and running. You can provision a cluster. And okay, and also, so why this is really revolutionary is that, it's very fast, and it's fast because, the compute is very fast. The computation that you can carry out with all these, with the clusters is very fast because it uses what we call data parallelism, which means that, so the computation tasks that you're trying to perform are distributed over all the machines. All the machines take different tasks and perform the computations for you and return your results in parallel. So not that one will wait for the other one to finish the computation before it does its own. And it's highly fault tolerant. So for example, if one machine fails, another one can take its place and fulfill the task that you want to perform, that you're trying to perform. I hope I'm making sense to you guys. I hope I'm not.
Yes, you are.
Going to. Okay, thank you for the feedback. All right, so that's basically Apache Spark. So Apache Spark is what. Wale. All right, thank you, Daniel. So Apache Spark is what these guys, let me say cloned. Like they have the open source one is just out there, and then they clone it and customize it to fit their own purpose. So that's what it's about. So you'll be wondering, oh, what is Apache Spark, or what is Spark exactly? What is Spark cluster? So you just know that a Spark cluster is a distributed collection of machines that run Spark. So it consists of typically it consists of one driver and one master. So what happens is that the master is in charge of other machines. So the driver and master are just machines. To just think about them as different computers. Like my laptop and your laptop there that you're using to listen to me now, they can be they're the machines. So let's say my own laptop is the driver, Amy's laptop is the master, and Daniel's laptop is is a worker, right? So that's what happened. That's the basic building block of a Spark cluster. Okay, so what happens is that the driver, my laptop, will interact with Kemi's laptop, which is the master. Then it will use that to locate where the other workers are, and then direct tasks to them and drive them to do those computational tasks. I hope that analogy makes sense. So just now, if you now think about it on a scale of hundreds of thousands of machines, so that's why it's really, 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 really fast. Okay. We have, I hope that has explained, the underlying technology behind Azure Databricks. So identify blah blah. Okay, so based on what we have just discussed, let's try and fill dependent data source. Okay, let's try and fill in the how. So the question is, we should outline how Databricks can be used to meet an AdventureWorks digital transformation requirement as outlined by the case study. So, Kemi, we have identified the requirement here, which is predictive analytic capabilities. So do you have, what do you think is the reason, hold on, how Databricks can be used? Okay, so this is the requirements, right? So we already know that, okay, it's Databricks we're going to use. So why do you think, okay, so I didn't talk about what exactly Databricks is used for. So sorry, Kemi, let me do that. Now let me explain to you. I've explained how the technology behind it and all that. So let me explain. I think I opened here exactly why. Okay, let me explain exactly why Databricks would be useful in this scenario, and hopefully by then you'll be able to answer that question. Okay, so you can see here what I was talking about, what I was rambling about just now. You know, Azure Databricks is a Spark-based analytics platform that is optimized for Microsoft Azure Cloud Services platform. It is designed with the founders of Apache Spark, and Databricks is integrated with Azure to provide one-click setup, streamlined workflows, and interactive workspaces that enables collaboration between data scientists, data engineers, and business analysts. Okay, so now let's look at the question again. So let's look at the requirements here now. Okay, so from this scenario that they've painted, why do you think that Azure Databricks, will meet will be able to fulfill that requirement there? So it's open to everybody. So I would like both of you to. 3 now. Nathan has joined us. So welcome, Nathan. I don't know if you got the question too. So I'm asking why exactly do we think that Azure Databricks will be a good fit, in this particular scenario, based on this particular scenario, given that, should I go over that again? Okay. Azure Databricks is a Spark-based analytics platform optimized for Microsoft Azure Cloud Services platform. Okay, it's designed with the people that made Apache Spark, and it is integrated with Azure to provide one-click setup, streamlined workflows, and an interactive workspace that enables collaboration between data scientists, data engineers, and business analysts. Now, looking at this scenario, please let me know why you think, the reason why you think Databricks will fit in perfectly to this scenario. Hello, guys. Hello.
Yeah, hello, Ale. Can you hear me?
Yeah, I can hear you.
Oh, okay. Okay.
Yeah.
I think one of the reason that we are setting up the Databricks or using Databricks for the requirement for for Adventure Works is because of it gives their team members the environment to collaborate.
Okay. Yes, I think that's a great answer. Any other answers or contributions to that? Nathan, Kemi.
I go with what Daniel said. It gives the team, like, what you define as Azure Databricks says that a collaboration between the data scientists, data engineers, and business analysts. And we can use something like that too in this scenario. So it gives them an avenue for collaboration.
Okay. All right. Any other? Nathan, do you have anything to add as well? Hello. Okay.
Not sure if Nathan heard that.
Okay. Hello, Nathan. Are you with us?
Hello, can you hear me?
Yeah. Hello. Did you get the question? Did you?
What was the question, please?
Okay, so we have identified the scenario that we want to work on, and previously we had determined that Azure Databricks is the right technology for us to use. We had all agreed in a previous session. So now I'm not sure how much of the discussion on Databricks you met. So now we're trying to say, okay, why exactly is that the right answer, or how does that fit into this? How does that solve this scenario for us, for the information services department?
Okay. What I would say. Okay. What I would say here is that Databricks that fit for this situation. First of all, according to me, that we are dealing with predictive analytics.
Okay.
So I think that's the one like influence like in this particular scenario, and like when we're trying like to deal with business analytics, and so I don't know like if it happens like in that situation.
All right. That's really cool. Thank you guys. Those were really great answers, because so for example, there are actually two reasons why it's good. It's a great fit for this this scenario. The first one is that it enables collaboration between the data scientists, data engineers, and data analysts, because you can use that you can create workspaces in Databricks and then share your work. You can see what everybody is doing. You can share notebooks. You can share ideas on Databricks. So okay, let me just say between the analytics team, so I don't type everything. Between the analytics team. The second one is that Azure Databricks is a compute platform, right? So predictive analytics is basically just a group of it's just mathematical equations, that you're using to that you're computing to make predictions, so and that's exactly what Databricks is very excellent at doing. It has machine learning embedded in it, and I will briefly walk us through that again. So it is a Databricks is a has 86. Great. And then wow. Okay. All right. So I guess these are the the major two reasons here. So let me just do a really quick run through of what Databricks is all about for Nathan's sake and for everybody's sake, actually, because I think I didn't touch on all of them. So it is, I've mentioned that it's this Apache Spark-based analytics service. So it helps it is very important in the pipeline in a big data pipeline. So what happens is that it comes in when you are trying to prepare and train your data, for predictive analytics, right? So if you can see here, let's say you have data, let's say you're collecting data from a business app, you're ingesting your data, let's say from a data factory, then you are storing that data in a particular storage of your choice, so you then feed it you connect your Databricks into your whatever storage you're using, be it your blob or maybe it's SQL you're using, or even Cosmos DB. If you're working with unstructured data, you can connect your Databricks there, perform your machine learning tasks, with ML flow. And when you're done, you can feed it into, let's say, storage. If it's unstructured data you're working with, you can, let's say, serve your the outputs of your training or your predictive model that you've not predictive model, like the outputs of your training, right? You can store them into a storage. Just going to have to sorry about that, Daniel. So yeah, so you store them in, you store your model and serve it. You can serve it to analysis services. So these are like where you store it in the back end, and then of course you now have an app that your consumer is using, or operational report like Power BI, analytic dashboards, and so on. So you can here is what Apache Spark is really based upon, like what it consists of. So you see that you can use it. You can actually use Databricks for a whole lot of things. You can use it for querying SQL data frames. You can use it to ingest things from Event Hub, your streaming and data from your sensors. You can use it to do machine learning, deep learning. You can also do graph computation with it. So all these are the computation aspects, and it supports a lot of there's 5 languages now: R, SQL, Python, and Scala. So yeah, so Apache Spark in Databricks has fully managed clusters. You don't have to really, be the one managing it. So all you have to do is provision and monitor it, and on their UI. It creates an interactive workspace for exploration and visualizations. So the workspace, you can add people to your workspace, as we'll see later, and you can make visualizations that you share. You can make reports and so on. So it's a platform for powering your favorite Spark-based applications. Spark is really awesome. It's a compute platform, like I said. It's distributed compute platform. and everything happens in the cloud, so you don't have anything on premise. You can create it in seconds. You can auto scale it based on your demands. We'll look at when we're setting it up, we'll see the pools, we'll briefly talk about what pools are, how pools enable you to auto scale up and down based on your demand. You can use the clusters, based on REST APIs. I think they have 2 APIs now, 2 different APIs you can use. Okay, so so it's really like so this is why it will serve for this purpose. The collaboration feature, it as we'll see later on, it helps us add people to a workspace and collaborate seamlessly. Many other what do you call it, Azure services, right? So as we saw in that architecture before, you can connect all kinds of Azure storages to Databricks, SQL, Data Warehouse, Cosmos DB, Data Lake, Blob Storage. And then you can also connect it to Power BI. So whatever it is that the output of whatever is coming out from your, you can always feed it to Power BI and make really cool visualizations of it. Yeah. So that was a brief run through on that. And all you have to do to know more about it is just come here to the Databricks documentation and read up on it. Like it's really cool. Yeah. Okay. So now we'll store a lot of connect to a lot of databases, right? So let's now discuss, what kind of storage, what data source would be the best, do you think would be best in this scenario to use with Azure Databricks? Does anyone want to try to answer that? So we can answer the second question. So from the lessons learned from the course and lab so far, what would be the candidate data source for the Azure Databricks instance we are configuring? Does anyone want to try? Hello, Daniel.
Yeah, it is. I think basically maybe I would love to leave the answer to that question to Kemi and Nathan.
You're slaying them. Okay.
Yeah, we talked about it yesterday in our lab.
Okay, so it should still be fresh in our memories now. So does anybody else want to try? Or Daniel, you can just spill it out if so we can all learn. Just move forward.
Okay. So yesterday we went back to see why we are using Databricks, and the reason was that they had historical reporting data and descriptive analytics data, and they wanted to have something that would give them predictive, a platform that they could use for predictive analysis on those data. And then we said the best storage for historical data is Azure Data Lake. So basically in this scenario, we are dealing with the storage that will be needed is a data lake storage.
Okay. Okay, does that explanation make sense to you, Kemi and Nathan? Why we need why historical data is best stored in a data lake storage?
Yeah.
Yes, it does.
All right. Okay, so let's say is storage here. So it's actually a Gen 2. There's a Gen 1 actually, but that won't meet the requirements of this. So what's the reason actually is because we are using historical data. Wow. It's being stored, right? Stored mission services. Okay. I think that those are we agreeing that these are answers, right? We are all agreeing, right? So it's not just me that is just typing. You guys are agreeing with us.
Yes, we agree because I remember that I just found out like in my notes like this is what we talked about yesterday.
Okay, all right, that's cool. So what I'm going to do now is before we go on to the next one, let me just show us just look at the answer. So we can compare. So split this now. Okay. So, so they said the first one is AdventureWorks would like to take their data analytics platform to utilize predictive analytics capabilities, which is, we got that one. So, and the reason is that Databricks is an appropriate technology because it is an Apache Spark-based analytics platform with one-click setup, streamlined workflows, interactive workspaces, enables collaboration between the data team, and we got that right, in the sense. So so the candidate data store is the data lake Gen 2, and it's because it can store a variety of data in a variety of formats in unlimited scale. All right, so so you can store a variety of data actually, that's right. And I think Daniel is also correct because it is this it has really unlimited scale, and I think the query time is actually also very much reduced. So historical data from whatever the information department is gathering will fit seamlessly into the data lake Gen 2. So yeah, I think we can say we scaled through this first task with flying colors. Don't close this yet. Okay. All right. We've spent a lot of time on just task 1. So let's go to we've actually finished task 2. Discussed on it. So now we're going to start. We're going to start. Let me start the next one. Task 2, 20 minutes. So what's going to happen is we're going to create an Azure Databricks Premier tier instance. So let me log into my portal. Actually, going to split my screen. I don't have to jump from one to the other. All right, hope this is like readable to you guys that are following, right? It's not so it's readable, right?
Yeah, it is.
Okay, all right. Fine.
Yes.
All right. So yeah, let's get to it. We have 20 minutes. So we're going to create a Databricks. We're going straight to task 1. At the top left corner, we're going to click home, create a resource. Databricks, Azure Databricks, Azure. All right, create. It usually takes a few minutes to create when you're done. So I don't have a create. Oh, okay, have just create it in here. Nah, I don't want to create it there. Create a new one. DP 200. Just leave it like that. 200. Workspace name. This is what we use. AWD BWSS CUD. Going to use Chem. Chemi. Okay. Subscription, not location. Okay. Already picked the subscription now. Resource group, pick that. Location. License here. Wow. Well, we're not going to be doing much, so it's not going to chop my credit. Anyway, then deploy Azure Databricks. No. Okay, so we're not creating. So we're not deploying the Databricks in our own virtual network, right? So let's go to review and create. It was already validated before. All right, it's validated successfully. Let's create that in. So yeah, as I said, it usually takes. That's really loud. Sorry. Welcome, Toby. Glad to have you here.
Good evening, sir.
Good evening.
And Mass. Well done.
Well done, sir.
Yeah, I want to dedicate tomorrow to practice. So I'll watch through the video from tomorrow morning.
Okay, that's cool. Yeah. So yeah, we've been talking about Databricks, how it's built, what it's all about. We've talked about how it's built on Apache Spark.
Yes.
I don't know, because I don't know when you joined us. So
yes, I just joined a few minutes ago.
Okay.
So Databricks, can you explain what Databricks, how Databricks comes in that Lambda workflow? I know what data factory is used for now, and some other names there. But this Databricks is like a little bit. I know it uses Apache Spark, is from Apache Spark and stuff like that. I understand Azure block storage, data lake storage.
Yeah. So where it comes in is whenever you want to start doing predictive analytics, and let's say, for example, in this kind of scenario we're doing now, where you have a team, let's say a data analysis team, a data science team, rather, that has to build applications for your company that has to do with predictive analytics, or even computer vision, right? You can train your models there, So where it comes into the Lambda architecture that I talked about is it connects to whatever data storage that you are using. Let's say you are using let's say you're working on sales records, for example. You can connect the. Sorry.
No, continue.
Okay, so you can. All right, so you can connect the Databricks to whatever storage they are using, perform your training. So that's the transformation and the transformation part of it. So you prepare and train your data sets you can do machine learning there, and then you create a save your model to whatever output it is that you in the next stage in the pipeline. So that's where Databricks comes in. That's
Okay.
the architecture.
Okay. I can see that is from this document. Use Databricks to read data from multiple data sources.
Yes, you can use it. Yeah, exactly.
Okay, thanks for the explanation. I think I got a little bit from that line.
Okay. Okay. If you need more clarification in any way, I can try and expand it a little more.
Nah, I'm good for now. I think the deployment is complete, so you can continue.
This where we are? No. This is it. Okay. All right. So it's been. Let's go to. What's this? Hold on. Let's deploy. Let's go to the resource. Okay. So. All right, so I've taken a shortcut. We've gotten to the resource already. So opened. So yeah. So we can see that the deployment seems to be successful. So let's launch it. Let's launch Databricks now. Check it out. Okay. Sorry, it seems my network is a bit slow. So, Toby, you understand what clusters are?
Yes.
All right. Okay.
Yeah.
So just signing in. We're going to be creating a new cluster now. Yeah. Start. Okay. Finally. Okay, so this is the user interface I was talking about. So you can see you have many options here, but workspaces, your data, what kind of data you're using, your connections will be here, and different clusters and jobs and your models that you've created. So what we're concerned with right now is creating a new cluster. So we're going to create a new cluster. Let's create a cluster.
Can you either use UI or JSON?
That. Sorry?
I said you can either use UI or JSON. I can see that there's JSON option.
Okay.
So for people that are very good
in
JSON.
Yeah. If you're very good in JSON, you can configure it in using the JSON. But the UI is much more easier.
Yes, but some people prefer that JSON.
Yeah,
because it's
frankly,
likely to have more options.
oh really?
Yes, sometimes like that, it will have more options for you to tweak some things.
Okay.
Then that's from my own experience. When there is a JSON, you have more
Option.
options to.
Okay. Okay, that's good. But I'll probably try it out one day. Okay. So yeah. So remember I mentioned something about pools. So a pool basically is an like a standby instance uh, of a cluster, that reduces the time it takes for the cluster to start and how fast it can scale. So you can now allocate clusters to a pool from resources to the pool, and whenever the cluster is done with that job, the resources it uses will be returned to that, and so it is now accessible to other clusters. So that's what basically this configuration is here for. But now we're not going to be using, any pool.
Okay. So, can I ask a question?
Right now.
Can I ask a question? Hello? Can you hear me?
Yeah.
Yes.
Hello.
So you mean that
Yes, I said
yes. So you mean that the pool is like something working like a concurrency stuff like that. It will allow two things to work at the same time instead of them waiting for each other.
no, basically Spark or what do you call it? The clusters already work in parallel.
In parallel, okay.
What this was is that yes, it will expand to accommodate
Other cluster.
So, and then when you no longer need those run around free resources and user.
Okay.
That's the way I understand this one. So Databricks already runs in parallel because it uses Spark, and Spark is a Spark machines as Spark clusters run in parallel rather.
Okay, got that.
Okay, so let's see. Okay, terminate after 60 minutes because we don't want to eat all my credit. Thank you. Okay, because this is very important because there are some times where you forget to turn it off, and you go home. You just wake up in the middle of the night with a bad dream. Okay, so remember this was what I was talking about. These are workers. These are like the virtual machines that will actually the computational work that you want. Okay, so we should leave all the remaining options in current.
Yeah, hello.
Let's create the cluster. Yes, hello. Daniel.
Yes.
Am I missing something?
Yes, just to add a little to what Toby asked. If you're setting up a cluster, for Azure Databricks, it depends on how many nodes you have and you are setting up. You need to specify that, and you could share that node. You could share nodes. All right, so that supports concurrent or parallel computing. So, for instance, you want to link, just like that diagram that Wale showed us earlier on. if you want to create a pipeline with a data factory, and let's say your data in this case is in data lake, and you want to process those data, but performing that processing serially would take a long time. How do you reduce the amount of time for data processing? Then you need to go parallel. And by parallel, you want to know then batch size and how many chunks you are going to have. So basically, if you are dealing with Hadoop, you would know the more of the concept with chunks of data, batch size, and all that. So basically, you can do that with Azure Databricks too.
Okay, is it that or by default it doesn't run in parallel? Because I thought that was the idea.
Yeah, by default it doesn't. So you have to configure.
Wow. Okay. Wow, I learned something now. Okay, thank you, Daniel. Really, thank you. All right, so I'm going to create this now. So you can see it's being created. Let me just expand this. All right, so while that is pending, let's see. So it's going to take a bit of time. Wow, they said 10 minutes, now be 20 minutes, okay? Okay, so what do we do now? Should we just sit docs? Let's see. Should be, this is going to take about 10 minutes to provision. So I'm wondering, should we start discussing the next lab, or should we just wait for it? What do you guys think?
Yeah, I think we could move on. When it's ready, we move back.
Okay.
To save time.
It vanished for a second. Okay, so let's see. It's really bad. Yeah. Should be in instructions. Sorry, okay, yeah. So Cosmos DB. Okay, so Cosmos DB is another really fascinating tool in the Azure chest, you know. So it's really amazing because it has a lot of APIs that you can connect with. So for example, and basically it is a platform for managing, storing, and distributing unstructured data. So we have I think four APIs that 4 APIs that it uses, including table APIs, Cassandra, graph APIs. We are talking about Gremlin. One more. Cassandra, graph APIs, table APIs, and SQL. Yeah, how could I forget SQL? No, not SQL. What am I saying? Oh my God. MongoDB. Yeah. Sorry. So it's MongoDB API, not SQL, and not BSQL, because it's unstructured data, right?
So sorry.
Yeah. Yep. Go ahead, please.
How about MariaDB?
Sorry.
I'm saying, like, my question is, how about MariaDB?
MariaDB.
Yes.
I'm not sure if that is supported. I'm not sure. I've not come across that in.
Because the reason why I mentioned MariaDB because I saw it like in Amazon. I don't know, like in Azure, like.
Oh, okay. I'm not sure. I'm not sure that is supported. I know MongoDB is supported.
Oh. Okay.
Yeah. Just seeing this for the first time. Statistically. I have to come and check this. Okay. Let me see the concepts. So I'm guessing we all know like the difference between structured relational databases and non-structured databases. So basically, so if you are having so what exactly is Cosmos DB? Cosmos DB is a globally distributed multimodal database system. So for that means that you can basically store all kinds of non-relational databases all over the world. Like you can make them available. You know, you can be in Nigeria and have them available anywhere within Azure's what they call it, regions. Okay, so didn't actually bookmark that one. Anyway, so let's look at this one for a guide. What we're meant to do. We should be able to describe and demonstrate the capabilities of Azure Cosmos DB. Describe and demonstrate the capabilities that Azure Cosmos DB can bring to an organization. Be able to create a Cosmos DB instance and show how to upload and query data through a portal or through a .NET application. Okay, so also describe what Azure Cosmos DB can do for an organization. So, like I said just now, you can, for an organization like, let's say, these AdventureWorks guys that are working with now, that are, that are renting bikes out to people. So you could have you can be in basically Nigeria and have a company that, or an app that is serving people in the US that rents bikes out to them, and and all the data they are seeing, all the pictures or images or unstructured data that they are seeing is stored, over there, and and you're not physically present, right? So that's one of the advantages that I can bring for an organization. It is globally distributed, and it has many different kinds of storages that are supported, as we just saw with their APIs. So you could, depending on whichever one that the core organization staff is more conversant with, you can structure the kinds of data you're collecting and serving to fit the API that you are more comfortable with. So it is, I'll say it's very flexible. Okay. I found something I wanted to share with you guys. Okay, so basically about the global distribution that I just mentioned, you don't have to be in a particular place before you can set up a data, your database, right? And it is based on their SLAs. It has high availability, and it has unlimited read and write access. It is very, very scalable. So these are part of the the advantages that it can bring to an organization. So that will help them build highly responsive apps. Apps that are always available 99.999%. Yeah. So should we talk about the consistency level? So let me because I think I saw some really some consistency level questions in that while going through the dumps. So I'm just going to touch on that now. So there are like two boundaries. There are two extremes of consistency. So we have the and when you're choosing your consistency, right? There's always a trade-off. You're always going to be sacrificing. You're going to have to choose which one is most important to you, whether it's between high availability and latency issues. So if you're going with really strong consistency, I think that means that there is more what do you call it now? Is more restricted kind of. I'm trying to remember the exact. Hello. Hello. I can't really hear you. Is that Daniel? Daniel, that's. Sorry, I can't hear you, Daniel. Can you guys hear Daniel? Because I can't hear you at all. I'm sorry. Okay, so anyway, you can keep trying to, or maybe change positions so you can get better network. Okay, so So rather than having the user choose between two extremes, they usually give us a spectrum to choose from. So as I said, there's always a trade-off no matter what you choose. But for most scenarios, right? For most scenarios, the session consistency is always the session consistency is always like suitable for most tasks that that you'll be engaged in, right? So yeah, so you have to be cognizant of the fact that you're going to be trading availability and performance when you're choosing. So all this comes when you're configuring your Cosmos DB instance, right? Okay. So now, if you guys remember, Daniel brought up, was it Daniel or Funani? Yeah, it was Daniel. Daniel gave us a discussion, like a brief on how you should, partition your Cosmos DB accounts, because that also, directly affects how you are built, So you don't want to make your partitions explode. So for example, let's say you have a Cosmos DB container or instance that has user names, like names of people, different people. So like a partition basically has to be something that is similar, that cuts across all the items that are stored in that container. So you don't want, if you have for example names, dates and name, dates, IDs. Sorry.
Wow.
Hello.
Yeah.
I should check what? Hello.
Oh.
Man. Sorry, I can't hear you, honestly.
Check WhatsApp.
Okay, I should check WhatsApp. Okay, so Daniel is saying, so the context here is that if you have globally distributed set of databases, syncing and getting updates to the central database can be an issue. So that's the source of the trade-off. So the thing is that there could be split-second differences in databases being consistent globally. So yes, I think I get your explanation. Okay, so you're saying that's the source of the consistency. Where is that again? The consistency trade-off, right? So, so if you select, so that goes down to the performance trade-off now. So if you have to now, select if you want it to be based on the session or something more extreme, depending on what exactly is. If responsiveness is more critical to the kind of application that you're building, so if latency is more important to the kind of app that you're building, you have to put that in consideration. As Daniel said, it's just like really split differences, because at the end of the day, there is really, really high availability, guaranteed when you're working with Cosmos DB. Or if a few seconds is critical to your deliverables, you might need to take that into consideration. Okay, so I will be going back to, I noticed that our cluster is up and running. So let me just switch back to. Thank you, Daniel, for that explanation. Okay, so we've confirmed that, you can see now the state here has changed to running, is no more pending. So we've confirmed that. Confirm that it's running. So the next task is to collect the data lake store Gen 2 account name. Okay. Excuse me. So okay. Done. The right place now. Access keys. No. Down. Yeah. Access keys. Yeah. Settings. Settings. No. Where can we find access keys here? Can be looks now. No. Screen. So the resource group now, then the data lake. Change this. Am I missing something? Daniel, I can't hear you again. Can someone help me out here? I think I'm missing something. Yeah, I can hear you very, very faintly. Yeah, hello?
P.
Look like Daniel has a problem with the network.
Sorry, can anyone hear Daniel?
No, like you can't. Like for me, I can't hear you.
Test. I'm really lost here. It's actually meant to be here. Like, first. Can't be lost now. One more.
Hello, Wale, can you hear me?
Yeah, I can hear you now.
Okay, great. Yeah, so you're looking for the access key. I think you should close this. Go to your notification.
Yeah.
Can you hear me?
I can hear you.
Yeah, go to resource. Yeah. It should be under overview. Okay. There's no property here.
At all.
It should appear like this. Oh, it's a managed resource. It's a managed resource. You probably might not have those details here.
Oh, okay.
Yep.
So I need to
just launch the workspace here.
Yeah, I've already launched it here.
It's launched, yeah. Okay.
But I need the access keys to connect the data lake gen to.
Let's see if you can do it from here.
From here?
Yes. So that you connect to. Are you sure it's not the data lake access key you're looking for here?
Yeah, I should. Is the access key now? No, is yeah, it's the access key.
Be sure it's not. Be sure they are not asking you in the task. I think it should be the one for the data lake.
We've not created a data lake yet now.
Okay, sorry. Please hold on. Except they've made updates to the UI. If not, it's supposed to be the same thing.
Coming to create a data lake first of all.
First. That's C3, right? No, it will show there. It will show. If you look at task 2, exercise 2, task 2. If you look at the side pane, you won't have those details there. You don't have it there.
I have these ones now. Okay, yeah. So yeah, so it's not the one that we're meant to be looking at.
That's why I said you are supposed to be looking at the data lake.
Oh, I see.
Oh, data lake was what we created yesterday.
Oh, okay.
You have to create a data lake storage.
That's what I was trying to do. This is genuine.
Okay, and that would be a long process. I would say, let me give you the key here.
Okay.
And let me give you the key here. So you can just continue with the one on Cosmos.
Okay. Anyway, so basically we've talked about the benefits of Cosmos DB that Cosmos DB can bring to the the organization. So
yeah, Wale,
let's say where, yeah, yes, hello.
yeah.
I can't hear you, Daniel. Hello. Okay. I can't really hear
Can
you.
you hear me?
Okay, I heard what you said just now. Okay, so I can't hear Daniel. I'm not too sure if we'll be able to run through all this, but I'm just going to speed through it. Let's say we have a scenario where developers in the information service department, they know about Cosmos DB. They want to understand the capabilities that the service can offer and how it would bring value to adventure works and in what circumstances.
Yes.
Yeah, hello.
Can you hear me now?
I can hear you, but it's still breaking.
Okay. Send the probably.
I can't hear you. I can't. Like it's breaking badly. Okay. Okay, so we want to understand how the service can be set up and how data can be uploaded. So like the developers would like to see an example of an application that can be used to upload data to the Cosmos. So both would like to understand how the claim of planetary scale can be met. So that means, excuse me, they want to know, they want to see the Cosmos DB at work and also see how, they can see it in real, like in action, this global of Cosmos DB. So Cosmos DB also takes a lot of time to deploy, about 10 minutes, even longer than Databricks. So probably I'll do it sharp, but just be prepared. Anyway, so we're going to create an Azure Cosmos DB database. We'll insert query data to the Cosmos DB and distribute the data. So let's see how you create the Cosmos DB. Let's create an account. What API are we using? SQL. I'm going to delete it once we're done. Okay, don't create. So this usually takes a while. Takes a while, about 10 minutes. So while that is going on, let's probably discuss more on this trade-offs of global distribution, the consistency levels. So Daniel was trying to explain to us before, on the kinds of trade-offs that will be facing. I don't know if you guys can see his chats on WhatsApp. So one scenario that we could have is, the syncing between a branch, let's say a bank branch in between UK and, let's say they have another branch in Nigeria. They're trying to sync their data between themselves, right? So the kind of consistency that you select will kind of affect maybe by split seconds, the time of it will take to load update the data between the two branches.
Yeah, Wally.
Yes, Daniel.
Can you hear me now?
I can hear you now.
Yes, I can hear you now.
Great. Sorry, the internet service is just somehow. Tonight, I didn't expect it started before the call. Yeah. So I think this portion of the exam is really core. I believe it's one concept Microsoft would want users of this technology to really, really understand. So the flow here, as you can see from that diagram, it's pointing to the fact that if you are implementing strong for your consistency level, you would have real-time update, but less availability. And then the more, if you switch to bounded state, the availability increases, but consistency reduces. So consistency reduces from left to right, but availability and throughput increases from left to right. So here's the thing. A perfect example is this. Say you have a company A has, or a company, let's say AdventureWorks, that has branches in Germany, in Paris, in Japan, different parts of the world. They are using Cosmos DB. In each branch, they need current data. For instance, the company at the headquarters just made a new a bicycle that they want to sell. If they add that bicycle, maybe the image, let's say, for instance, they are using Cosmos DB, and they add the image of those bicycles to the database, the amount of time it should take for the other branches to see this image on their website is either going to be strong or eventual. So, for instance, you as a user now, you are in the let's say the headquarters is in US, and you are in Japan. You want to buy bicycle. If the image they just uploaded it now, and you want to buy this at the same time at Japan, you might not see the image. You might not know that there's a new bicycle. Do you understand?
Yeah.
Because of lower latency, you might not know that there's a new bicycle, that the headquarters it has been added at the headquarters, and those in US can see it right now. They can see it on the website right now, but because you are further away, and the time it will take for the copy of the database in your own location to be consistent with the database at the headquarters. If it's eventual, it simply means you are going to see it at a later time. Okay, so probably you would have bought your bicycle before you know that there was a new bicycle that you could afford, and it would have given you would have loved that one better. So that's what this is explaining.
Okay. Thank you, Daniel. So how far with are you done with this explanation, or do you want to?
Yeah, so that's basically it, except you want to drill down. So you can just, I think you can focus, you can use these guarantees associated with consistent level to understand it.
Yeah. Also, there's still more detailed explanation about the performance trade-offs here. If you're
Please
interested,
try to share the link.
Of course, I will. Let me just drop it on the.
And we don't have Nathan in the WhatsApp group.
I'll share it on the WhatsApp group now.
Yeah. Hello, Nathan. Oh, Nathan. Is Nathan? It's like Nathan is off.
I think it's just two of us now.
No, he was on now. I think maybe network or something.
Okay.
He just left now. Yeah, Wale, you can continue.
just two of us here.
It's being recorded.
Okay. Okay. So personally, I didn't really get this consistency level stuff. I get that, like the trade-off pass between availability and performance, right? That's the syncing, right? So, for example, this linearizability now. So what does okay, it refers to serving requests concurrently at the same time, Abby. So if excuse me. So for example, if 10 people want to buy the bicycle in Japan, for example, it will give. Okay, you mentioned the real-time updates. Okay.
Yeah.
Okay. Other stillness. Consistent prefix guarantee. There is lag behind writes by most K versions.
Yep.
Okay. Oh, so there's just a slight lag in the loading of the.
Yes.
Okay, I get it now. So as you go from stronger to eventual consistency, say here it says lower latency as you increase. Or shouldn't it be higher?
High throughput.
So throughput is the amount of. Yeah, I'm listening.
So performance amount of
items,
say query or processes, or the performance of the database different region.
Okay. That really covers. Wait, what do you? Yes.
Yeah.
The time, for example, that picture to load in Japan. Is that not what the latency is addressing? So I was thinking the latency should increase as we move from the stronger consistency to eventual consistency.
No, scroll up first. So still scroll down, sorry. So you can click that availability and performance trade-offs, that link. I want to see what they explained here about performance. Okay. So for instance, now in this case now, strong actually means a write is not complete until all write has been done on the different branches. So let's say we have three regions, one in US, one in South Africa, one in India. If you are doing a write from the headquarters in US, that write will not be committed until the same write has been performed on the other regions.
Region. Okay.
Yeah. So that operation only completes. So let's scroll down first. I want to see the throughput listing. Okay. I think majorly it's performance have to be about what the query, the amount of time it will take to run query and all that. So remember, there's a copy of it at that region, yeah. And in that same region, there's processing ongoing, right? So the performance at that place will be faster if you are using a lower consistency level. So for instance, in India now, the performance of this database, write, read in the copy with the data copy that is there, the performance of the database there will be high than compared to when you want the latest data, the current data. If you want the current data all in all regions at the same time, then you have a lower performance in all the regions.
Yeah. All right. Makes sense, I guess. So we've actually exhausted our time, Daniel. So?
Yeah, we have. I think this is basically what we should. We finished the one for Cosmos DB, right?
No, we haven't. We're just deploying Cosmos DB now.
So let me see the lab.
Oh, it's just complete now.
Okay. Oh, there are still further tasks down.
Yeah, there's still some down. Just need to add
container.
Data, then add data to in the emulator and query it. Just show how to query it, and yeah, that's basically it.
Okay. I think we probably will just take this as assignment.
We can pick it up tomorrow.
We'll take this as assignment. So what we'll do is that we'll just do a brief description of what has been done from this lab, and then we continue with the next lab.
Oh, okay.
Yeah.
Thanks for all the help. I actually learned a lot because I've seen, in the dorms, right? I came across a lot of questions on the consistency levels pertaining to
consistency level. Yeah.
Yes.
That's why
Although
I said
I got although I got some of them, I was just using an intuition. I didn't really understand it, but now I think I get the trade. I didn't understand the trade-offs, so now I think I kind of get them now. I'll read the docs again.
Okay.
Yeah.
All right.
So that means I need to create the. You said you were going to send me the data lake. So maybe I'll just create my own and run through the lab.
Okay. So because of my network, I couldn't log in.
Okay. No.
All right. Yep. So enjoy.
Yeah. Good night.
Good night.
I'm going to stop recording now. Oh, you're the one recording, so yeah. Don't forget to stop the recording. All right.